This is problem 41 of chapter 16 of Giancoli 6th edition. What we have is an electron. They give us the mass of this electron, and it's accelerated in the uniform field. So they give us the magnitude of this uniform electric field, which is this electric field is coming is created by two parallel plates which are charged. Okay, so we have here these two parallel plates charged, and that's why we have this electric field in between them. Okay, and the separator between these plates is also given to us is 1 centimeter. We also have this distance. And the electron is accelerated from rest. So we have this electron here initially at rest. This is the negative plate, and this is the positive plate. So it's at rest near this negative plate, and will accelerate, and there is a little hole here, and this electron will keep going through and moving away. Okay, so we want to know what is the exact speed that the electron has right here when it goes through this hole. Okay, so how are we going to get that? Well, to find this speed right there, it would be very good if I had the acceleration, right? Because then we could use our old equation, v squared equal to v naught squared plus 2a delta x. So if I had the acceleration, I would find this initial speed, this speed when it passes the hole, because initially we know it's 0. This delta x, it's given to us is that 1 centimeter, so 0.01 meters. And so if I had the acceleration, I would be able to find the v. Well, how can I find this acceleration? A good way to find an acceleration is to have the force. If I have the force, I know that the acceleration is ma. So no wonder they gave us the mass of this electron. All right, so things are looking good, but from where can I find this force? Well, they gave us the electric field. So I can find this force using the value of the charge of the electron multiplied by this electric field. Here I'm just playing with magnitudes, no signs, not anywhere, equals to ma. So we can find a. Once we have the acceleration, we can then find v. And then there is one last question, which is why the gravitational force can be ignored in this problem. Well, in all of these problems dealing with electric field, we don't take into account the gravitational force. You could have said, well, won't this electric field fall due to gravity? The component of this gravitational force is negligible. And you can check that. The gravitational force, mg, is so much smaller than the electric force that this electron will feel. That's why we don't take into account any contribution from the gravitational force.